Lesson number 101 is about multiplication of exponential expressions and variable bases. Now our first problem is to simplify, and we have 5 squared times 5 to the third power times 5 to the fourth power. Now one way we could look at this problem would be to say, well, 5 squared, that's 25, because 5 times 5 is 25. 5 to the third, that must be 125, 5 times 5 times 5, and 5 to the fourth power, that's equal to 625. Now to simplify, we could go through and we can multiply 25 times 125 and take that answer and multiply it by 625. If you really like to do multiplication, you're welcome to do that, but you don't have to. There's an easier way to find the answer to this problem, and that's to look and see 5 to what power total. So here in the beginning we have 5 to the second power. Then we have 5 to the third power and 5 to the fourth power. So if we look at the 5 and how many powers of 5 we have, we can write our answer that way, and it's considered completely simplified. Well, we've got 5 to the second and 5 to the third. If we look at that, that must be a total of 5 to the fifth power, because 2 plus 3 is equal to 5. And then if we look at 5 to the fourth, that's 4 more powers of 5. So we have 5 plus 4, that's 9. So our answer is 5 to the ninth power. And when we have 5 to the ninth power, that's exactly the same thing as saying 25 times 125 times 625, and it would also be exactly the same thing as finding the product of this. Both of these answers will get you full credit, but working with this, 5 to the ninth power, is a little bit quicker, and it's easier to read and easier to write. Let's look at another problem. Here we have 10 to the 15th times 10 to the 17th. Now this is an example of a problem where you wouldn't want to write out the full answer in expanded notation. And that's because it's a huge number. So we could go ahead and we could simplify it by saying this is going to be 10 to how many powers? Well, in order to fill in this box, we're going to have to say 15 plus 17, because that's how many powers of 10 we have in total, and that's 32. So 15 plus 17 gives us 32, so 10 to the 15th times 10 to the 17th is exactly the same thing as 10 to the 32nd power. Let's look at another problem. Here we need to simplify, and we have 2 cubed times 5 squared. In this problem, well, since our bases are different, one has a 2, one has a 5 as the base, we have to simplify by multiplying. 2 to the third is 8, because 2 times 2 times 2 is 8. 5 squared is 25, so 8 times 25, that's like having 8 quarters. It must be 200. In this problem, we have to simplify out to get our answer written like this, because we can't figure out how many powers of each we have, because the bases are different. We've got one more example today. We need to simplify, and this time we only have variables. So what we need to do is we need to figure out how many powers of a we have, then we need to figure out how many powers of m we have. So this is a, it must be a to the first, because if there's nothing written, well, it must be the first power in order to have it there. So for powers of a, well, we've got a to the first and a to the second. In total, that must be a to the third. And then we've got a to the fourth, so 3 plus 4 is 7, gives us a grand total of a to the 7th power. Then next, let's look at our m's. We've got m to the, well, that must be to the first. Then we've got m to the 5th and m to the 6th. So we're going to get m to the 1 plus 5, that's 6, and 6 plus 6, that's 12. So we get a to the 7th, m to the 12th. We've got our final answer. We could box it and move on to our next question. Sometimes these problems with variables only are even easier because you know you've got the fully simplified answer right here. Lesson practice will be on page 315. Make sure you've got your notes complete, and I'll see you during our next class.